Alright, so this video is going to cover the repair of this 32-inch Bush LED TV. The model of this TV is not really significant because this applies to pretty much most LED TVs. This is a Bezel built set, but as I just said, it applies to Samsungs, LGs, and pretty much any LED TV. Now, this is a full array type LED TV, which means it has LED strips in the back of the panel, whereas there's the edge lit type, which are slimline like this, and they have LED strips in the side of the panel and a massive diffusion plate which takes the light from the LEDs at the side here and evens it across the screen. But this one has LEDs right directly behind the LCD glass. By the way, the LCD glass is the screen at the front. Now the TV is actually on at the minute, but you notice no picture. Why is that? However, and I don't know if you're going to be able to see this on the camera, if I press the volume button, what's that? You know, you can see an image on the LCD display. You can see that. And if I press menu too, you can actually see the menu. I'll get my torch here. And camera isn't picking it up that well. I did clean the bottom of the screen because the screen is quite grubby and the camera might not be picking it up that well, but if I change channel, you can also see the channel bar. But the easiest thing to see with the camera is the volume bar. So, what is this? Because the LCD glass is working, and in a dark room the screen is pitch black, but the screen isn't being lit up. Now, the most common fault on LED TVs is that actual LED bulbs fail. And the reason for this is because of heat. Basically, the LEDs and LED TVs are wired like Christmas lights. They're in series, so there's an LED there, and there's an LED there, and an LED there, and an LED there. And they're all connected together, and they all rely on each other being able to work for the circuit to be complete, basically. So if an LED there fails, the one behind it can't light, and the one in front of it can't light, and the whole strip won't be able to light. Is the best way that I can describe it. And what happens is, over time, the LED gets pretty hot, and they do get very hot in these TVs, probably because they don't limit the current that well on them. And they get really hot, and the dye on them cracks, and as soon as that happens, the bulb is basically what's called open circuit. And the contacts inside no longer work when the dye does crack. And if the bulb fails open circuit, it means none of the others can light, because they all rely on each other basically to work. And if it does short circuit, it'll burn up pretty fast. And sometimes it'll stay short circuit and the rest of the bulbs will stay lit up and work. But if it does short circuit, normally it'll get really hot and it'll burn up and then fail open circuit. But this video is going to cover the repair on the actual backlights. I'm not going to be replacing the LED strips in this. A lot of people, when they get an LED TV and they diagnose a failed LED strip, they don't think of repairing them, they think on finding replacements. And finding replacements for TVs is pretty hard and it's pretty expensive, but if you're able to obtain LEDs, you can actually replace the bulb on the original strips, which saves you money and can save you time. And you can, if you have the bulbs on hand and the equipment to replace them with, you can do it in a day. And I'm going to hopefully get this done today in this video. So what we're going to do is we're going to flip the TV over. Now I can do that with this one because it barely weighs anything, and let's just look at the back. It's a Vestel set, but as I said, it applies to all LED TVs. And what you're going to do first is you're going to take the back cover off, and there's several screws around the outer case here, and you have to take the stand off too on these. And then the case is actually clipped together, so you need a pry tool to get in there, in between the top case and the front bezel, and you need to snap the clips apart, and then you can take the top cover of this off. And then we're going to do some other diagnosis first, just to prove that we have a failed LED in the panel, because the LED driver could also be at fault on this, but likely we have a failed LED. So let's take this TV apart quick. So here's inside of this TV, and before we take apart the LCD module, and as I said before, the LCD module is the panel which has the frame, the LEDs, the diffusers, the reflector, the LCD glass and the bezel at the front there. So before we take that apart and try and diagnose a bad LED, we're going to make sure our LED driver is correct. Now, if you don't know what an LED driver is, it basically creates the high voltage for the LED strings in the screen. Now, normally TVs, higher end ones that are better build quality than something like this, will have a separate LED driver board, and it's just like a little PCB which, you know, connects to the panel and drives the LEDs. Now, if you don't know how to find your LED driver, look up the model of your TV and type in LED driver after it, and you should be able to find your specific board and find out which board is the driver. Now, some of them, like this, will have the LED driver built onto the power supply. So this is the power supply here. It's a 17 IPS 19-5 from Bezel. This is the main board, and this is the T-con. Now, you see this connector goes into the panel, and that's where our LED strips are. They are connected here, and this section over here is the LED driver. So to check that, it's easy. You need a multimeter, set it to 600 volts DC there, and all you need is your positive and negative probes here. So you're going to put the black probe on the chassis, and then you're going to use the red probe to measure what voltage you get at this connector here. Now we're going to do that. I'm just going to set the camera up on the tripod. Hopefully I'll get a good shot. So the TV is currently in standby, by the way. And I think I'm going to set it up so you can see the meter instead. So hopefully you see that. So make sure you have a good chassis ground there. So you should see, I think, about 60 or 80 volts. I'd say probably 60 volts on this. So we're getting 22, which is unboosted. We get 90 volts, and it's slowly decreasing. So what's happened there is the LED driver has attempted to start, but it's detected, the control chip has detected that the LEDs in the panel haven't lit up and the controller isn't running anymore. So what it does is it then turns off the driver and the voltage decreases across the filter caps like this, as you can see. So we're just going to check our 24 volt rail, which is what drives the MOSFET, the booster MOSFET for the LEDs. And the 24 volt rail is good. So now that we've seen that the output of the red connector starts high and then it falls to low, we're now going to measure the black wire on this, and we're going to see what voltage we get across that. Now I'm going to measure it at this end, but it doesn't really matter where you measure it. And you should see a similar type of voltage coming back through that. Maybe a bit less. So this is on the black connector, and it jumps up, and if we compare it to this one, it's gone to 0. So that basically means we have a bad LED within the panel, and the driver is shutting down to protect itself, basically, because it doesn't want to run the LEDs if it's not lighting up. So what we're going to do now is we're going to turn off the TV and we're going to take it apart. And you're going to have to take the whole screen apart to access the LEDs. Pretty difficult to do, but to take the screen apart on these you have to remove the stand, and it's pretty much the same on most Vestel TVs and pretty much the same on any other LED TV. You have to take the stand support off, you then unplug the T-con, go into the LCD screen, and the LCD screen has its own little PCB here. On these you have this plastic cover which screws down into the plastic frame of the TV. 4 screws along the outside, and then the front frame you can just pull off the TV. It has little clips and you just bend them outwards and it will unclip and come off. And of course make sure your mains AC is disconnected there. So now that we've diagnosed that the LED driver is indeed working and that the return voltage from the LEDs is not what it should be, we're going to take this panel apart and then we're going to start diagnosing for a bad LED. So I'm going to start taking this thing apart now. When I take the front frame off I'll do a video then. On these TVs as well, these Vestel TVs with this VES type of panel, the actual LCD glass isn't supported. The only support for it is the plastic frame around the edge here. So when you take, if you are doing a Vestel set, but pretty much most LED TVs, you want to be really careful how you take the panel apart. So I'm working on my bed here because I haven't got a workshop because I'm too young to own one, but when taking these screws out for the corner, what I do is I put my hand under the set and I keep it supported rather than pushing down on it to undo the screw. And I undo it that way, just so it doesn't flex the LCD glass because it's very, very fragile. If you've ever broken an LCD screen, which I have never broken one by the way, you'll know how fragile and easy they crack. And if you crack the LCD glass, well, you may as well just chuck the TV away because it's just trash then, because you can't find replacement panels hardly anywhere. So now I'm going to show you how to take the front bezel off. So on these Vestel ones, as I said, after you've taken out the screws you can unclip the front bezel, and to do that you just get your hand in between the actual plastic and the metal of the frame and you just undo the clips by pushing upwards. If they don't come undone, don't force it, just work on the other ones. And it may take a few tries to get the clips actually off. It's not the easiest of jobs on these TVs, but there we go. Takes a few tries on these, but hopefully I can do this on video. If not, I'm going to have to pause the camera there. But okay, so what I'm going to do is pause the video. I'll pause the video just so I don't damage anything, and then we'll take the front frame off. So when you've undone the clips, just lift the LCD frame bezel off, and then you make sure you unplug your front panel connectors too. Now I'm going to set this down here, and here's the LCD screen, and I'm not sure if this has been tampered with before because the actual tape that holds it on has come off. So, but on these Vestels you have some tape here and I just completely peeled this off. Sometimes I'll replace it with electric tape afterwards, but I just literally peel it off, get rid of it all, because as soon as you take it off the first time it's not going back on properly, if you know what I mean. And I think I've seen Samsung, I did a 40-inch Samsung LED and that had the same type of tape on it, and you know, it wouldn't re-stick afterwards, so it's best just to either replace it or just get rid of it altogether. It's probably not holding the glass. So next we're going to work on our tab-on drivers. These you want to be very careful with. This is our tab-on driver, and this is the tab-on driver PCB, and You want to make sure you undo this before you can take the actual LCD glass out. And this particular one has a couple of screws and some little latches to hold it down too. You just undo the screws a fair bit. Now I've unplugged the connection from the T-con to the tab bond driver, as you can see. Some of these TVs don't even have a T-con, so you won't have to worry about that, but anyway, after you've undone the screws, you can literally take it out this little rubber here. And I'm not sure if you need to undo it the whole way, but pretty difficult to do, to be honest. But you want to do it carefully, then fold the tab bond driver over and stick it down with some double-sided just stick it down with some electric tape, and then I'll show you what I do after that. So I've stuck my tab bond driver PCB like this. It's, in my opinion, the best way to do it. So now we're going to take the LCD glass out the frame here. To do that, you should use a pry tool, but I'm just going to use my hands there. You just lift the LCD glass up very carefully, lift it out the way, and then put it on a padded surface like this, sorry. And that's all you have to do. Try not to knock it either, because they crack like nothing basically. Only takes a little knock and then it'll be game over. So keep that somewhere safe. And now we're going to take off the diffuser layers for this LCD module here. So on these Bezel ones we have this black plastic around the edge, and this has clips on it all around the outsides of the TV. And you just use a pry tool to get those off. And when you've got all those off, you can take this black plastic around the edge off, and then you can take the diffuser layers off. So I'm going to take all these clips out quick. Try not to crack them either, because if you do snap these, that's less support for the LCD screen, and which will make it less reliable basically. By the way, here's the tool I use to take these little clips off. It's a little spudger from an iPad repair kit for an iPad screen, and you start off around the edge. You just use it to unhook the clips basically, and this works really well. I've bent it into an angle, as you can see, but if it was straight, it's really difficult to like get up there and get the clips, if you know what I mean. But at an angle like this, you can just go like that, and that's the first row pretty much off. And it's the same for the outside one, so I'll do that now. So when you've undone all the clips, you can take this plastic bezel off, and it doesn't matter what like if you lose the orientation of it, because it only goes on one way anyway. So now we have this white sheet, and that's our diffusers. And to take these off, you just grab them all, and it lifts off. Now keep these in the exact same order, because if you don't, it's just going to cause uneven light across the screen. So when you've taken those off, you'll see we have these little bulbs here, and we have this white sheet. And this white sheet is our reflector. It basically reflects the light bounced off of the LEDs back to the diffuser, so you get even light distribution. And this is held down with some double-sided tape, because it's cheap on this one. But higher end ones like Samsung and that, they will actually use clips to hold the reflector down. And it doesn't matter if you crease this or whatever, because it does crease pretty easy. Try not to rip it though. So when you take that off, you will see our LEDs here. Wonderful devices. So we're going to test the LED strings, and firstly, before we do test the actual LED bulbs, we're going to make sure that this contact board here has a good connection. Now, another common issue on LED TVs, apart from the LED bulbs failing, is this contact PCB which links the LEDs together. the contacts on this get worn and they don't work anymore. Easy way to test that is with your multimeter on diode mode. So, and you just set your meter to diode mode or continuity test, and if you have continuity you'll hear a beep. So this first pin is the positive input and it goes straight to the plus side on this string. So I'm going to set this in a way that you can see it, if this tripod would work. It's a bit of a cheap tripod off eBay, but oh well. So we're going to set, it doesn't matter which probe you set where, but we'll put the black one on the input and then we're going to test it on the other side of the LED string. And we should hear a beep. That means it's good. So now on the LED we have a negative side, which is the output side, which then goes to the positive of this LED string. So we're going to put a probe on the negative side there and then a probe on the positive side on this one. You heard the beep. That means the connection from going to the positive side into this strip and then from the return line into this strip is good. So now on this last string here we have a minus pin and then we have the return pin on the actual connector there. So we put our probe there and just make sure I'm doing this properly. Oh dear, we're not getting... Scrap that, we are. It's just my probe wasn't in properly there. So, doing that test proves to us that the connection from this green PCB, which links the LED strips up, is good. So now that we've confirmed that, that means one of our LEDs on the LED strings has popped. And I'm going to get my test power supply, and if you don't know what I mean by that, go onto my channel and watch my ATX test power supply build video. I will link it in the description, and we're going to test these LEDs here. And you're going to need the test power supply, which can provide up to from 3 volts to 12 volts. And you'll need a very small screwdriver, flathead type, to scrape back the solder mask on here. And you'll need a set of probes to be able to test these LEDs. So I'm going to get that set up now, and then we can start testing these properly. The only way you can test them, the only other way, is with a multimeter, but it's much harder to distinguish which LED is bad with a multimeter. But you can do it. But I'm going to use a 12 volt test supply that I built, and we can test this. Here is my test power supply. As you see, test supply do not use in PC. I'm not going to talk much about this, but this supply on the yellow connector has 12 volts, on the red connector have 5 volts, and on the connectors with green tape around them I have 3.3 volts on the black wires in the middle. And there's 22 LEDs in this panel, so that's 22 individual LEDs that are going to need to be tested. Each LED uses roughly 3 volts per LED, so each one of these little domes here has an LED under it which uses 3 volts. So to make my life easier on testing these, I'm going to use 12 volts at the start so I can test a group of 4 LEDs. Now if you do the math, 12 volts, 4 LEDs divided by 3 volts each, that means, you know, it's 12 volts you have to put across 4 LEDs to make them work. And say if you find 2 LEDs that don't light, or 2 LEDs that you want to test, put 5 volts across them, they will light on that. So I have my meter probes plugged into 12 volt at the minute, and the black one is hooked up to ground and the red one is hooked up to 12 volts. Then we're going to test the LEDs, and then I'm going to show you how I find the bad ones. So now I'm testing the first 4 LEDs, and it's pretty easy to do. You put your red probe on the plus symbol on the input there. You go down the strip and you're going to scrape off the solder mask with your spudger. It's easier to do it with that. And that's where you're going to put your black probe. I think that should work. If that one doesn't light, then I have to move it a bit further down, but I'm going to just try this here. Normally you scrape off and put the negative probe one space after the last LED you're going to test. It's 12 volts here, and as you see, these 4 LEDs light, and it is one space after you after the last LED you're testing. So these 3 at the top will work, and this one here also works. So that's the first 4 LEDs in this TV confirmed working. So now I'm going to do the first 4 on this strip. It's easier to test them in groups at the start, and then you can narrow it down to find out which LED is bad. So you just scrape the solder mask off there. And do the test again. My camera's probably about to fall over, so if it does, I'm sorry. And those 4 are also good. So now we're going to do this LED, this LED, this LED, and this LED. Grab that. So we're going to do these 4 now. Same method. Scrape the solder mask off. And before the LED that you're testing, oh my bad, it's actually already been scraped off. So it's pretty difficult to work in actually, because it's such a small space to do it in. But I can only get 3 in the frame at the minute. But you're going to put your positive strip there and your negative strip there, and we're not getting any light emitted from these whatsoever. And the black probe is being connected. So, as this 4 or these 4 here don't emit any light, one of those is likely bad. But we're going to need to test these 4 as well to confirm that all of them are good. So as you can see, these 4 are good on this first strip, and now there's 3 at the end here on both strips, and I wouldn't recommend you use 12 volts to test 3. I'd recommend that you go to 5 volts and then test them all separately. So we're going to do 5 volts for these 2 and then 3.3 volts for the last one there, just because I don't want to burn it out, because if you apply a voltage that's too high across it, you'll burn out the LED. It doesn't look that neat scraping this off, but you know, it doesn't really matter. So we're going to do these 3 at the end here on the second strip. So to change this to 5 volts, you just unplug the red probe there and plug it into the red wire, which is 5 volts on this power supply. So we put a voltage across these 2, they light up, and I doubt it'll light all 3, which it doesn't. So now instead we're going to put it across, we're going to put 3.3 volts across this last one here to test it instead. And there we go. Now we're going to test these at the end of the first strip, changing that back to 5 volts. We can test these 2. They light up. Now to 3.3 volts, and that lights up. So we've concluded that the first strip is good, but we have a failed LED from this one to this one. So now we're going to test this strip individually. So we're going to put a scrape after each LED So as you see, we have one there, one there, one there, one there, one there. Keep the power supply at 3.3 volts. First LED. No light emission whatsoever. That one is probably our bad one then. The second one. And that's my meter probe. That one lights. Third one lights up, and the fourth one lights up. So what it actually helps is you have one lying around, use a Sharpie or any other type of marker that you have, and this LED gives no light emission whatsoever. We're going to put a tab by that to say that this one is the bad LED. So now that we've found our failed one, just turn that off so I can talk. You just take your spudger and you're just going to pry this little lens off. It's really easy to do. It's stuck on there, you just get your spudger under there and pry upwards. And I can actually see that this LED is burnt, so that means it's bad basically. And the zoom on this camera is horrible. You can see that it's actually burnt at the end there, the traces. So I'm hoping that this LED hasn't burnt the trace off when it failed, but if it has, I'm going to have to repair the trace, which is pretty difficult to do. So before we actually go ahead and replace this, we're just going to put a voltage across it and see if it lights up at all. And nothing. So this LED has failed in some way. It's failed open circuit. So that confirms we have one bad LED. There's 22 in total in this panel. It only takes one to fail. As I said at the start, it's wired like Christmas lights, and it's the same for all these LED TVs. Only takes one to fail, and then the whole lot don't light. Example of cheap modern junk. So now I'm going to get my bag of replacement LEDs and I'm going to replace this failed LED. It's pretty easy to do. You need a hot air station. You can't really solder these with the soldering iron because as soon as you touch it, the tip of an iron on there, it literally just melts the LED straight away. So it's best to use hot air in my opinion. And then you're going to need a glue gun so you can stick the lens back on afterwards, because without that lens the light won't be directed properly, so you'll have a patch in the screen that's lighter than the rest of it and it will look rubbish. And that's all you need, and you could do some IPA if you have any, so you can clean off the flux residue afterwards. And that's basically how you replace an LED. So I'm going to get my hot air station set up. Now a lot of people tend to pry the strips out of the TV, and you can take these strips out if you want. They're just adhered to the back of this metal chassis here. And you can take them out if you want to replace the LED, but I find it easier just to replace the LED inside the set. Now as we're using hot air, you want to make sure there's nothing behind the actual LED that can get melted, like this fragile LVDS cable, but luckily it's not directly behind that. So this LED is safe to remove without making sure anything is unplugged. So I'll do that now. So here's all you're going to need to repair this. I have my hot air gun. I have a bag containing lots of little SMT 0.5 watt LEDs, which I salvaged out of other TVs. Now the question you might be asking, where the hell did you get these from? The answer is smash screen TVs. I brought some smashed LED TVs, took the backlight strips out of them and salvaged the LEDs off the actual bulbs themselves. To do that you literally just pry the lens off and heat the area and take off the LED, and then you can reuse it. And I have some resistors here. Why have I got resistors? I'm not actually going to be using them to drop the voltage, but what I'm going to do is, to help prevent future failures with this connection strip here to the actual LED strips, I'm going to solder the solid wire part of the resistor onto the actual strip here. And soldering it is more reliable, and it means the strip isn't going to have an intermittent connection over time, and it just means that the chances of me having to reopen this panel to fix it again are going to be less, because I don't hate taking these apart, but it is a bit cumbersome to do. So I've got something under the TV so that the hot air doesn't melt my bed, and I'm doing this on the bed because I really can't be bothered to do it anywhere else. It's just a quick tutorial. So I'm going to get the camera positioned as best as I can, because this is pretty difficult to do. Okay, so I've got some flux here. I have this spudger, but that's only really to solder the resistors on. And I have some very fine little tweezers. So I'm going to take an LED out of this bag here. Do that. I'm just going to grab one out of random. That'll do. Now on the bottom of the LED you will see there is a large pad and then there is a small tab. Hopefully my camera can focus, because this camera is pretty annoying. You see there's a larger tab and then a smaller tab. The larger tab is the positive input and the smaller tab is the negative input. And you want to make sure you follow that correct layout on this LED as it's on the original one, because if not, you'll burn it up. Now I'm using flux not because I want this to come off quicker, but because when these short out, they can tend to get stuck to the actual copper trace, and what can happen is you'll pull the trace off when trying to remove the LED, and using flux I've found helps reduce the risk of that happening. So we're just going to start heating, as you can see. And I'm just literally going to go in there with my little tweezers and just go side to side for a bit. It'll take a bit longer of heating, of course. Might have to turn the fan speed up a little. It really doesn't take that long to unsolder one of these. There we go. So there's the bad LED desoldered. And with this, you chuck it away. In the bin. Or in the trash, whatever you call it. So now there's a bit of flux residue left on the board there. And I actually find it easier to remove this and apply fresh flux again. And then the flux actually is helpful in a way. So we're just going to clean that off. Just got IPA on there just to clean that flux off. As you can see, the actual area's gone a bit brown because of the heat, but I'm using 400 degree air, if I didn't already say. And if you have a look, that is really nice and clean. And that's our positive tab, and that little tab there is the negative one. It's the same on the LED as well. Okay, so now let's put that aside. Oops. I'm just going to get a bit of flux here, and the flux helps the LED flow into place easily. And you just put a little blob on like that. And just get your new LED. Again, be very conscious of the polarity. Just doubly check before you put it on there. So there we go, and you're just going to roughly align this. Just drop it on there and just roughly align it. Now the flux will melt the solder, and then the solder will actually take to the LED nice and easy. And we're going to turn the fan speed way down. Now, it might move a little, and you might have to realign it a few times, but as soon as the solder goes molten, it will take into place real easy. I think the fan speed's probably a bit too much. A bit all over the place you are, aren't you? The LED is actually just soldered itself, but not in the position I want it to be soldered. Turn that up a bit more. I don't want to damage the pad, so get it on there nice and even, like that. There we go, that should do. And ta-da! That's how you replace an LED. So I'm just going to get some... where are they? Where's that? Christ. So I haven't got my toothbrush in here to clean that, so I'm just going to use some tissue again. Normally I'd use a toothbrush to clean this off, but spray a bit of flux cleaner on there, just get that flux off. You gonna focus camera or what? There we go. Okay. I just like to clean around the LED just to make sure it's nice and clean. Installment. Okay, and that's that LED replaced. Ta-da! So now we're not going to use the power supply to test this, because if this isn't soldered in properly and we use the power supply to test it, we're going to burn that LED up as well. And I don't want to have to replace that a second time. So use your meter in diode mode. It's in diode mode, and if it's soldered properly, your meter actually provides enough current at a low enough voltage to light this LED up very slightly. And if it is soldered properly, it'll light up. And if you was to accidentally short it out, say if you improperly soldered it, it would burn up. Using your meter to test it, if you soldered it improperly, it wouldn't burn it up. But if you was to use the power supply to test it, and you'd soldered it improperly, it would burn up very fast. And, you know, replacing it a second time is just a pain, but as you see, that LED works. Awesome. So now we're going to get the power supply hooked back up, and we're going to test this row again. Okay, so we're going to test this LED after we've replaced it. I have the power supply set to 12 volts. And I really do urge you, if you are testing this after you've replaced it, don't look at that LED. Just don't. You know, hold the probes on, and worst comes to the worst, hold a bit of tissue paper, which is what I normally do. Just hold a bit of tissue paper over it like that, without looking at it directly, because, and there is a way you can do it. I'm going to look at it through the camera LCD screen because it's less bright on there, but without the lens on, that is pure light coming out of that, and it really does burn your retina if you are to look at it direct. So, you know, protect your eyes at least. I'm looking at it through the LCD screen of the camera. So that's 1, 2, 3, 4. There we go. So that is all on there. So that completes testing. So the next stage of this repair is going to be getting this little lens back on there. And all you need for that is a hot glue gun. You can use silicone if you want, but silicone takes longer to set, and I'd rather just get it done straight away. No messing around. So I've got my hot glue gun on at the minute, but it takes ages to heat. So I'm going to wait for that to heat, then I'm going to show you how I get the lens mounted back on properly. And then we're going to test this whole panel all together. Before we seal up the panel, we're going to test it, because if this is still, if it does break down afterwards, you know, I still don't want to seal it up and then find out that the backlight still doesn't work for some reason. And then after we've got that on and just made sure that the panel lights up properly, we're going to do the modification to this board here and solder the resistor wires across there. You can use any wire, but I just choose to use resistor wire because it's nice and, you know, it's solid aluminium wire basically, and we can do that. So just wait for the hot glue gun to heat, and there you go. On some strips it will leave like this brown mark on the board, or on the actual strip, after you've heated it, but on some others it doesn't. And I've replaced LEDs on ones that, mainly the Samsung ones, that don't leave this brown, you know, burn patch afterwards, and it looks factory. You can't even tell the LED's been changed. And actually, whilst I'm on the subject of making something look like factory, toolbox is a mess. I'm going to get my side cutters and I'm going to snip off the residue of these little plastic stoppers here, because it's easier to do that. I've just found them actually. It's easier just to snip that off because it makes it easier to glue. Careful not to cut the LED whilst you do this either, because that'll be a shame. You're going to have to change it again. Oh, camera, I wish you'd focus. I hate this camera. There we go. That should be alright. Just to get the lens on there a bit more firmer and flatter, so the light coming off of this is like the rest of them. So I'm going to wait for this to heat up now. Okay, so the glue gun's heated. So if you can see, I might zoom it out a little bit. I'm just going to take the excess off there. I'm going to put some dabs of glue in each corner. Now, don't get the glue directly on top of the LED, that's stupid. Just cut off the strings there. And it's hard to do this with the flipping camera in the way, but now, of course, if you know anything about glue guns, you know that this glue is going to be dried, you know. So how's it going to stick the lens down? Well, the hot air station comes in here. I've set it to 100 degrees. Fan's a bit too fast. And we're just going to heat this glue until it becomes molten again. Then literally set this on top. By the way, I hope you can see how much glue I've got in there. Just a little second of just heating that 100 degree air. There we go. So let's set there. Just going to put a little marker by that LED just to show that it's been changed. Ta-da! Set on there nice and solid. So what we're going to do now is plug the TV in and make sure that we get backlight properly now. So I'm just going to get the plug for the TV. Okay, so I'm going to plug in the mains AC now. I hear the power supply doing its usual noise, so we're going to turn this on. Might be a bit bright, so just look away for a second, or look through the LCD screen. And ta-da! Now this, I can tell, is on full brightness, which is the reason why that LED failed. Look how hard they're driving those little LEDs. Even with my test power supply, which has way more current, it was dimmer. So now that we've seen that it all lights up, and the one that we've replaced lights up too, I'm going to do the modification to this board, and I'll show you how I do that. But that's the backlight fixed, and just got to do that mod, and then this should be case closed on this one. So I'm going to show you how I do the modification on the LED strip here, and help make sure that this doesn't become intermittent over time due to the connection breaking down between the branch off board here and the actual LED strip. I use a resistor. I use the solid wire end of the resistor and just basically solder that and then branch it off to the connection on the LED strip. Really easy to do, and it's effective as well, because it means that this isn't going to break down and you don't have to tear this thing apart afterwards or a few weeks after. So firstly, we're just going to confirm the continuity. So you'll notice on this tab here, if I could zoom, there's a tab there. Now, before you use solid wire, you want to make sure to check the resistance of that tab. Now, you want to make sure that this does not connect to any of that, and I've got the meter and diode. You want to make sure that these two tabs, because there's two, there's one there and one there, you want to make sure they're not shorting out, because if they are, you can't use solid wire to do this, and if you do, you have to isolate those tabs. But they're not shorting out together, and they're not shorting out to the chassis. And they're not even shorting out to the contacts. So it is safe to run the solid wire over those tabs, hopefully you can see that, over those tabs to the connections there, before anyone has a meltdown on me for accidentally touching the solid wire on that. It's okay to do it, don't worry. So I'm going to show you how I do this here. I've got my soldering iron, by the way, and what I do firstly is I'm trying to make sure I don't get in the way of the camera. I just add some solder to the ends there, and a bit of the smoke from the solder does go on, stick on the lens, by the way, so just clean that off. And I straighten out the wire on there, but before I actually go ahead and install the wire, it's probably easier to use a flathead screwdriver, but you can use that spudger, which I've talked about several times. And you're just going to scrape the solder mask off of this branch off board here. Scrape a fair bit off, so now we have bare copper exposed on there. So we're going to take our soldering iron here and I'm going to tack some solder onto those bare copper traces there. There we go. And then we take our resistor lead, just touch it on the connector strip there. Oops. And that's all you have to do so that's attached. Then you're going to fold it around, hover it just over the where you've exposed the copper there. Use some side cutters, snip that off. And then we're going to solder that. There you go, and then as we've soldered that point there, we're just going to add a bit more solder to the point on the connector. And that is solid. So now we're going to do the same for the other polarity on this. Just straighten out the resistor, just literally, straighten out the lead like that. Might be a bit more difficult for me to film this, but I'll try. Yeah, I'm having to do this with my left hand, and as you can tell. Okay, that's just temporarily on there, but we can sort that out after, just make it a bit more better. And my side cutters are getting a bit worn, as you can probably tell. There we go. Okay. Hopefully it actually filmed what I was doing there rather than just my hand. Oops. Just add a bit of solder on there, then we're just going to tack this down a bit better. Ta-da! I'm not going to bother cleaning off the flux on that because it doesn't need it. But if I get this camera off here, just turn that. You can see the mod. Just turn my head torch off there because the camera doesn't like it. So basically just made a dead short with a wire, which is more reliable than this little connector house there. Just made a dead short from the contacts, and that is going to make this a lot more reliable. So I'm going to do the same on this one, and then we're going to start reassembling this sucker. So I've completed both the wire mods there. So now we're going to start reassembling this, and I'm not going to really do much updates on that, but it's pretty simple, to be honest. You notice we have some double-sided tape here, and that's sort of wearing down. So we're going to reapply that double-sided tape, and I'm going to put some in the centre of the panel here, just so that the reflector doesn't dip inwards, which can cause light defects on the display. And I'm just going to add some double-sided tape, and I'm going to put the reflector in first, then the diffusing layers, then the plastic bezel. Then I'm going to talk about the what you have to be careful of when putting the LCD screen back in. So I'm going to get on with that. So I'm just about to seal up the panel. Just got my initial on there. Here's the new double-sided tape, and I'm going to start sealing this up. So before you put the LCD panel back on the diffusing layers, you want to make sure there's no dirt on here, so any like little dust balls or whatever, you just want to make sure it's completely clean, because if not, you'll see it when the actual TV is on. You'll see whatever's trapped between this and the LCD screen, so you want to make sure it's clean. Normally just blowing under it whilst you set the screen down, or make sure that you don't get anything like that, but nearly reassembled now. So I'm going to make sure that that's not the case when I reassemble this. One thing I'm doing on these to help the reliability is I'm putting some thermal paste on the tab bond drivers, which actually have a little thermal pad, which is that black tab there. It has some copper in it. Just put some thermal paste on just so they can cool a bit better, because we're going to be seeing a lot of tab bond issues with these in the future. In fact, we already have been with these Vestels and other LED TVs. Just helps them cool a bit better, because these tab bond drivers have quite a bit of responsibility. The horizontal row drivers are actually built into the panel, but which is why that metal is around the edge there. It's a heatsink for that. But it's just something I do now. So I'm going to seal this up. I've also cleaned the screen, as you can probably tell. Okay, so this section is not really going to be part of the actual LED repair, but this is a Vestel TV, and whenever I get one of these ones with this IPS19 or any other LED supply that uses diodes in parallel for the output, I replace the diodes because they have a very common habit of blowing up. Because Vestel they don't rate the peak reverse voltage properly for the diodes, and it basically overvolts them on startup until they recover, and sometimes they go short circuit. So I'm going to be replacing all the diodes. These are brand new. They were installed on a board that I decided not to use and swapped it for another one. If you want specific details, the board I installed these on was a 17PW25, but I found a 17PW26 which is more reliable and decided to take these off. These are SB5100s here for these three at the top, which are for the 12 volt rail. These two are UF5402 for the LED, rectifies the voltage coming off the LED boost MOSFET, or the boost transformer. And these are UF5404s for the 24 volt rail. And these are all brand new parts, never used diodes. And I'm going to replace these. Then afterwards I'm going to reflash the firmware on the motherboard. But you can do that with the back of the TV on, it's easy enough to do. So I'm just going to get on with this quick. Okay, so I've re-dioded this power supply. I don't know if I already said it, but I say re-dioded because if you ever replace bad caps on a TV, you call it recapping, and on these power supplies it's pretty much essential that you replace the diodes, because if not it's just going to blow up, you know, a few weeks down the line. And as I've said before, I'd rather not have this fail, you know, 2 weeks down the line after I've sold it, because I don't want to get a bad reputation. So replace the diodes with brand new parts on the power supply. It should last a bit longer. I've added a heatsink on this main CPU as well. Even though it does have a heat pad going to the panel, I just prefer to add a little heatsink on the top. I've got quite a few of those little block type. And then what I'm going to do is I'm going to reload the core update software for this motherboard, which will help make it more reliable too. And I'll show you how I do that after. This isn't really to do with repairing an LED backlight, but this is just something I do. Things that I take pride in, because I'd rather, keep my reputation good. So now I'm going to put the back cover back on and reconnect everything, and then we're going to turn the TV on, reload the firmware, and then we're going to test this for a while. Right, so sealed up the TV, and I've got the firmware upgrade plugged into the USB port. So we're going to update the firmware, and it should flash really fast like that. And I could do that for a few minutes whilst the update loads, and you can actually see the USB being read. Well, that's just installing the core update folders from fresh, basically. And I've got the aerial hooked up too. So it takes a few minutes, like. It should just boot right up. And of course you can see me in the reflection. When it goes down to slow flashing LED, that means the update has worked. And it should come up with the first time installation screen. It does take a while on some of them. On some Vestel TVs it takes about a minute to do, and some like this it takes about 3 minutes. I think I've even had one that had a corrupt firmware folder take about 6 minutes to load, and it wasn't the JMB one that I did a video on either. But you just have to leave it until it boots up, because if you do unplug the USB it'll mess it up. And there we go, we're booting. There we go. And here's the menu up. So the firmware upgrade has worked. I'm going to go straight into... Actually no, I'm going to go install and retune. I'm just going to unplug that USB Now the backlight is on full brightness at the minute. We're going to want to turn that down in a second. We're going to go first time installation, yes. It's going to reboot and it's going to install everything from fresh on this. I advise you do this on any TV whenever you service it. Just reinstall the whole lot from fresh. It just helps it be a bit more reliable. So that's going to scan the channels, and when that's done I'll show you what else I do to help make these LEDs a bit more reliable. Alright, so I'm going to go into the menu, and I'm just going to change the source because the camera seems to struggle to focus on digital TV. So I'm going to go into the menu, I'm going to go to picture, and I'm going to set this to dynamic, and then I'm going to set the backlight to low, and I'm going to keep it at that because on low the backlight isn't having to work as hard, which means that the LEDs are going to be less likely to wear out. Now on auto, if you do cover the sensor at the front, it does go low, it does go dimmer, the backlights go dimmer than the low option, but you'd have to block off the cover on the front and the IR sensor basically, and that's just too much faff. And going to advanced settings, and I like to set the dynamic contrast to high on these, because if not it looks horrible. And everything else should be alright, so keep the backlight on low, and that's the same for any other LED TV. Put the brightness way down to its minimal on the backlights. It is watchable like this. You know, it doesn't look that bad. I mean, the image quality is shit, but with the brightness at that level, it's alright. You can still view it. It just means it's going to be less stress on the LEDs, and the picture is a bit broken up there. Now one thing I do as well, I already did this when I was assembling the TV, but oops, is on these Bezel ones, if you go to settings and you go other settings and you turn the blue background on, so you get a full blue screen, just check over the screen and make sure there's nothing trapped behind there between the screen and the backlight, and just have a look around, because that's a full solid image and you can see, and on this one there is nothing. But that's going to conclude this video on the repair of an LED backlight. It's the same for any LED TV, and really, trust me, turn the brightness down as low as it can go until it's watchable, because if you just run it at high, you're just going to have to take this whole thing apart again a few weeks down the line, or a few months down the line. That's not fun, because the more you take that LCD screen out, the more flexed it's going to get, and the more chance of a tab bond failing. And of course, you get a tab bond failure on these, it's basically just scrap. And also, I had someone on bag caps try to say that you know, actually replacing the LEDs direct and using hot air to replace them isn't as reliable as doing other methods. Like there's a stacking method, and if you want to learn about that, go onto bag caps and find Budham's thread about stacking LEDs to replace them. And there's other methods like replacing the entire strip, and somebody called Michael, he's on about replacing the LEDs with brand new ones. Replace every LED, not just the bad one. But I've done this type of repair, and I've had TVs sold for over a year now, which, by the way, this is only 16 months old when it failed, or when the LED popped in it. So to have one sold for over a year, which failed pretty much within a year, you know, that's pretty good. And I'm just loading up something on eBay here. And a guy called Michael was on about replacing the LEDs direct with something like this. High power SMT type LEDs, and I suppose it would work out a bit better replacing all of them, but that's a lot of work, and it's easier just to replace the one. And as I said, I've had TVs that I've done this type of repair on sold for a year, and I've sold several others that I've done this repair on, and they've been, you know, perfect. So, and these aren't going to last that long anyway. A TV as cheap as this, and even good ones like Samsung's, the LCD screens in these LED TVs, they're just not reliable. They just quit out after a few years of use, and of course when that happens and you need a new LCD screen, you may as well just chuck away the TV, because it's not economically affordable to do that on such a crap ass TV, to be honest. But anyway, it's been a LED backlight repair. I hope this helps somebody out, because a lot of people get stuck on this, and if they can't find the LED strips, they'll just chuck the TV away, which, you know, why do that, you know? If you can repair it, why not? And I'm just going to show you how I source these LED strips too. And here a second. 40-inch LED TV. It's a full array type, like the one I repaired. Screen is smashed on it. I don't know if you can see the crack, but the screen is smashed. Just to back it up. And I'm going to take the LCD screen out, chuck that away, take the backlights out of it. And you can find smash screen LED TVs on eBay for about £10. And it can, you know, it can be really useful to have them. So, thanks for watching. I forgot almost to do this, but this is the final segment of the video. Press menu, then press 4725. And I'm going to find out how many hours this has on it. And that's a fair few. 507,000, 507, 2, 3, 4, divided by 60. This has 8,453.9, well, just 8,453 hours on it. That's alright for a Vestel, you know. I'm saying that like it's good, but it's not. For a Vestel TV it is though, because these are just so crap and the signal's messing up so bad, but it's not too bad. I've seen these only survive. In fact, I've seen a 32-inch Linzar which only had like 500 hours on it before the diodes blew on the power supply. So I'm pretty surprised that it has lasted this long. But I have had others, like I would have uploaded a video before this about a Polaroid 40-inch that had like 8,500 hours on it. Yeah, it's not the best, but it's not bad for a Vestel piece of crap TV like this. Anyway, final segment done. Thanks for watching.